Okay, we're going to solve the following exercise. The exercise is the number 2.4. The magnitudes FA equals 40 newtons, FB equals 50 newtons, FC 40 newtons. The angles alpha equals 50 degrees and beta equals 80 degrees. Graphically determine the magnitude FA plus FB plus FC. This is the diagram. This is telling me refer to the following diagrams when solving problems 2, 3 through to 5. The first vectors FA, FB, and FC lie in the same plane. Okay, the things that we have to do here, and I know, and this is an advice, is that you have to always use the diagram that the exercise is providing to you. Why is that? Because when you are solving these kind of exercises, the redoing maybe the what is happening with these kind of vectors is going to take you a lot of time. Sometimes, not in this case, but the advice is always use the diagram that the exercise bring. Okay, so what I'm going to do here is to use this diagram. In this case, I'm going to move this FB vector right here in order for it to touch the head of one of the two other vectors. In this case, I'm going to choose FA. Okay, so this is FB, and I'm going to draw in red. Well, not in red, maybe in green, the FC vector. So in this case, I'm going to draw this vector, and I'm going to say that this is the FC vector. So the answer will be this one. Okay, this is the answer for FA plus FB plus FC. Alright, remember that the only thing that you have to do when you want to solve a graphically magnitude, when you're adding some different vectors, the thing is that you have to put those vectors head with tail, and the result will be closing that shape by touching tail with tail and head with head. Okay, so this is the answer. I'm going to start playing with degrees and with geometrical features right now. So please bear with me while I do that. I know that I've already said that you have to use the figure that the problem is providing to you, in this case this one, but I want to make sure that you understand what I'm doing. Okay, so I'm going to do that again. In this case, I'm going to draw FA right here, FB right here, and FC right here. Why do I want to create that kind of shapes? Because I want to. Remember that I could move maybe FA right here and FC right here, and the result will still be in. So this is FA, this is FC, and the result will be this one, FA plus FB plus FC. Okay, and that is going to be the same result as the one that we are getting. So I need this magnitude, and I'm going to start playing with the angles. Okay, so this angle will be right here. Let me put it in cyan. Right here, this is alpha, and with respect of FB and FC, the same angle will be right here. So this is equal to beta. In this case, I'm going to write down the information that the problem is providing to me. So FA is equal to 40 newtons, FB is equal to 50, FC equals 40 as well, alpha equals to 50, and beta equals to 80. Okay, so I'm going to write down that information in my new diagram. Hence this is equal to alpha, and alpha is equal to 50 degrees. I have 80 degrees right here. FA is 40. Right here I have FB equals to 50, but I don't want to confuse later, so I'm gonna place it right there. And FC equals also 40. Okay, so let me change this color and this color. Because of this, I have right here a value of 180 minus 50. That equals 130. But I want to make sure. Yep. 180 and 30, sorry. Right here I have an angle of 180 minus 80. In this case, this is 100 degrees. And I have to start playing with these angles that I have right here. The first thing that I want to do is to create some different triangle shapes for me to start noticing what do I have right here. So here I have a triangle. Here I have a triangle. All right. Here I have the biggest one and the one that I need in this case. So I'm gonna need these two lengths for sure. Let me move this. All right. Let me create a line right here. And I already know what I'm going to do. At least I think so. Okay, what I'm going to do first is to say that this is 50 degrees and right here I have an angle of 90 degrees. So you have to remember that every summatory of the angles within a rectangle triangle, that means a triangle that has a 90 degrees angle, has to be equal to 180 degrees. Hence I have right here that 50 degrees plus 90 degrees plus x degrees has to be equal to 180. This is x. Okay, so right here I have that 180 minus 140 equals x. Am I right? Yep, I'm right. Hence x equals to 40 degrees. So I'm gonna write down that here. $40, and now I can find this value. I'm going to call this, I don't know, h. I have the hypotenuse, I could get the result as follows. So right here I have, and I'm going to use sine. Sine of 50 equals h divided by 50. Hence h is equal to 50 multiplied by sine of 50. H is equal to 50 times sine. I have to make sure that I'm using degrees. 50 is equal to 38.3022. I'm going to use just 4 significant digits after the comma. Well, I have the value of h. I need the value of the other part of this, in this case this one, that I'm going to call I don't know, that I'm going to call, I don't know, m. In this case I have this measure $100. Okay, right here I have these two measures, and I know that the whole measure has to be 180. So I'm going to create once again an equation that is going to say that 140, that's the symmetry of these two numbers, plus x, or I don't care how I'm going to call this, maybe f, plus f is going to be 180 degrees. Hence f is equal to 40 degrees once again. So in this case f is equal to 40 degrees. I'm going to delete this 40 degrees. I already have one measure and I can get the m value. Let me change the color of m. Color green. This is still cyan. So I'm going to use cosine. Cosine of 40 equals m divided by 40. M is equal to 40 multiplied by cosine of 40. M is equal to 40 multiplied by cosine of 40. 30.6417. Okay, I already have this measure. Now the one that I need is this one. Although I'm not sure. This is a little bit difficult for me to know. This. Okay, this is equal to 40. Since this is equal to 50, I'm going to create something that looks like it. Okay, the question that I want to do, or the question that I'm asking myself at this point, is if this point is before finishing this length. Why is that? Let me explain myself. I have right here a vector that has 40 as a magnitude. Then I have a vector that has 50. Then I have a vector that has 40. So in this case, the limit of this vector has to be after this limit. So how can I make sure of that? Well, there is a way in which I can assume that, and I'm going to take that. I'm going to assume that this point, as I just draw, is after this limit. So I gotta look this measure for me to get that. Okay, because if not, how am I going to be able to find the value that I need? Okay, what I can do right here is to find this value. Why is that? Because by finding this value and by finding this whole value and subtracting those two, that means I'm going to subtract this part, I am going to get this full part, even though if I assume that this is correct, or if this, let me draw it better for you, or if this is correct. Okay, so I have to have this measure, and this measure. Okay, so I'm gonna still using this notation right here. I'm going to look for n, and I don't know, and k. So sorry, k. So if you want to look for k, then I have to create a equation that looks like this. The cosine of 50 is equal to k divided by 50. In this case, the k will be equal to 50 multiplied by the cosine of 50. This is equal to 32.1393. Then I'm going to look for this value, and this value is n. So I'm going to use the sine of 40 equals n divided by 40. So 40 multiplied by sine of 40 equals n, and that is equal to 40 multiplied by the sine of 40. 25.7115. Okay, I already have all that I need. I'm going to say that this value that I need, call for example C will be equal to 40 plus k minus n. Okay, 40 plus k minus n. Then I have this value. So C is equal to 40 plus k 32.1393 minus 25.7115, and this is equal to 40 plus 32.1393 minus 25.7115. 46.4278. I already have the length of this and the length of this. So the answer will be by applying the Pythagoras theorem, in which I'm going to say that the value that I need, in this case FA plus FC plus FB, is equal to the square root of 46.4278 evaluated to the second power plus m plus n, nope, m plus h, m plus h evaluated to a second power as well. And the answer will be square root of 46.4278 evaluated to the second power plus m is equal to 30.74, so sorry, 64, 30.64, 17 plus h 38.30, 22. This is evaluated to the second power, and the answer is 83.1192. This is approximately 83.1. Okay, this answer that we get right here will be maybe a little bit close to the real one, since I'm not using the whole decimals. Okay, there is going to be a mistake right there. So maybe the answer is close to 83.1, maybe it's 83 or 83.2, although this is a normal mistake because I'm not using the whole decimals after the point. Okay, one way for me to look at if that's close to the correct value is by using a software. In this case, I'm going to use CATIA V5. Remember that I have some different tutorials in the channel. If you want to learn how to use this the software. So I'm going to create engineering draw right here and a sketch. Going to select the plane, and I'm going to start creating the lines that will give me the result. Okay, in this case I need this line right here. This has a measure of an angle of 50 degrees. This has an angle of 80. This has a particular value, this has a particular value, and this has a particular value. And I'm going to change that right here. The first one is 40. Second one is 50. The last one is 40. Okay. Okay, I have everything I need. And I'm going to create our result. This line. Now I just have to measure the length of the line, and right here we were pretty close, actually. The answer is 83.119. In this case, newtons. Right, guys? And this is how this exercise could be solved.